So we are working on rationalizing denominators, which we have already done once. We're just going to put a little bit more of a twist on it. So if you recall, a fraction is in simplest radical form when the only radical sign is the numerator. We cannot have a radical sign in our denominator. So if there is one, you have to do what we call rationalizing your denominator. So for example, this one is all good. There's no radical in your denominator. It is purely in your numerator. This one here is also all good. Because again, no radical in your denominator. It is purely in your numerator. So these three, those three need to be fixed. So who remembers, how would we fix that? You multiply by the radical. So if we look at my example down here, 18 over radical 6. Remember, you multiply the top and bottom by the radical 6, because radical 6 over itself is a 1, so really you're not changing your fraction, you're just manipulating your numbers. So your numerators you would multiply across, so you'd get 18 radical 6. Denominators, 6 times 6 would give us a radical 36 down there. But what is the square root of 36? 6. So then 18 divided by 6 would give us 3 radical 6 as our final answer. That would be our simplified form. A lot of times it does get rid of the fractions. Every once in a while, it does not. So note, always multiply by radical if just one term. Separate my T and my E there instead of making them all one. So if it's just one term, like we've had, also known as our monomial, you just simply multiply by the radical. Even if there's another number there, it's just the radical that you're multiplying by. So let's try 2 more examples just to refresh our memory. So for number 1, we would multiply the top and the bottom from the by the radical from the bottom. So both of them by radical 3. Your numerator here, you would have to distribute that radical 3 times both terms up top. So radical 3 times 1 gives us radical 3. Radical 3 times radical 5 gives you radical 15. So radical 3 plus radical 15 is our numerator. Denominator, when you multiply, you get a radical 9, which turns into, what is the square root of 9? 3. And although 3 and 15, you can divide them by 3, but up top, those are under radicals. So remember, you can only divide if everything's under a radical. I don't have a radical in the denominator anymore, so that's going to be my most simplified form. All right, let's try number 2. What are we going to multiply for number 2? Radical 2. Just whatever's in the denominator, so we're multiplying by radical 2. So distributing up top, we would get 4 radical 24. And then times that negative 6 makes it negative 6 radical 2. In our denominator, what do we have? Radical 4. So we can simplify 24. If you need to, you can kind of step out of the problem for a moment. What's the perfect square that goes into 24? 4 and a 6, and I put that 4 out in front. Square root of 4 is a 2 times the 4 that was already in front of my radical, makes it 8 radical 6. So I'm going to plug this in here. So I have 8 radical 6 minus 6 radical 2 is my numerator. Square root of 4 is 2. This one, though, we do have to reduce. Can we divide 8 by 2? Can we divide 6 by 2? Yeah, so we have to go ahead and do that. So 4 radical 6 minus 3 radical 2. That ends up being our final answer. So those are the ones we've done. Let's take a look at the back. So my little thought bubble there. Are we going to use the same process to eliminate this denominator? Does it look like our other denominators? No, because what's different this time? No. It's got 2 terms in the denominator. So our process is going to be slightly different. Still can't have that radical down there, so we still have to take care of that, and we still have to rationalize, but the process is going to become a little bit different. So to rationalize a fraction with a binomial denominator, so that means we got 2 terms in the denominator. First thing we have to do is you have to determine its conjugate. Determine its conjugate. Conjugate's a new word. Most of you probably have not heard of conjugate yet. Conjugate simply means flip sign in the middle. That's how we determine the conjugate. You simply change the sign in the middle. None of the other ones, just that one in the middle. So for example, this one up here, the conjugate would be radical 5 plus 2. I just take that minus, change it to a plus. That's all you have to do to determine the conjugate. You just change that sign in the middle. So second step, multiply numerator and denominator by conjugate. And then your third step is always to reduce. Last step, always reduce. All right, so let's take a look at number 4, example number 4 here. So we got a binomial denominator. We got 2 terms down there. So we got to first determine our conjugate. Conjugate tells us, again, just switch that sign. So our conjugate would be 5 minus radical 3. So our second step, we're going to multiply the top and the bottom by that conjugate of 5 minus radical 3. And it's always the conjugate of the bottom. So now we'll actually go through our multiplication steps. 6 times 5 gives me a 30. 6 times negative radical 3 is negative 6 radical 3. For the bottom, 5 times 5 is 25. If I distribute here, I get a negative 5 radical 3. Distributing that other radical 3, I'd get a positive 5 radical 3. and then a minus 9, or radical 9. Now the whole reason why we multiply by that conjugate is because then what happens with these terms here? They cancel each other out. So we don't even have to write those going forward because that's always going to happen with a conjugate. That's why we do it, is to cancel out those terms right there in the middle. And then the square root of 9, what does this turn into? 3. So I have 30 minus 6 radical 3 as my numerator. Denominator 25 minus a 3 gives me a 22. So then can I reduce all of those numbers outside of a radical by the same thing? 36 and 2. Can I divide them all by the same thing? Yeah, they're all even. We can divide them all by 2. 30 divided by 2 is 5. 6 divided by 2 is 3. 22 divided by 2 is 11. So I reduced it by dividing all the numbers outside of the radical sign by the same thing. All right, let's try again. So for number 5, binomial in my denominator, 2 terms down there. So I got to figure out my conjugate. What would our conjugate be of our denominator? Radical 2 plus 1. So that's what we multiply the top and the bottom by. Radical 2 plus 1. So we have to do some distribution up top. Radical 2 times radical 2 gives us radical 4. Radical 2 times 1 would be 1 radical 2, or just radical 2. It's the same thing. We don't have to write the 1. Now the 4. So we get a 4 radical 2 there. And then 4 times 1 gives us a plus 4. So we'll clean that up in a second. Yep, we'll have some canceling out in the bottom. So we got to first multiply the first 2. So radical 2 times radical 2 gives us radical 4. Those middle terms are going to cancel out, so the only other thing I have to multiply down here are the last 2. So negative 1 times 1 gives me negative 1. So let's clean things up. Our radical 4s, both are going to turn into 2s. So up top, 2 plus 4 will give us a 6. 1 radical 2 plus 4 radical 2 would give us 5 radical 2. And then in the bottom, 2 minus 1 would give us a 1. So we could leave our answer like that, but do we have to write the over 1? No. So you could also have your answer like this. So you can leave it over 1 if you want to, or you can write it just like that. All right. What are we going to multiply our top and our bottom by? 2 radical 3 minus 1. That would be our conjugate, 2 radical 3 minus 1. So we'll start distributing up top. Multiply the numbers outside, so 2 times 2 gives us 4. Multiply the numbers underneath, 3 times 3 gives us 9. And then times a negative 1, so that's negative 2 radical 3. So then we'll distribute that negative 1, so we get another negative 2 radical 3. And then a plus 1. Negative 1 times negative 1 is positive 1. So then underneath, all we have to do is multiply the first 2, which again gives us another 4 radical 9. And then multiply the last 2, which will give us negative 1. Multiplying conjugates, all you have to do is multiply the first 2, multiply the last 2. So let's clean this up. Square root of 9 is 3, but times the 4 makes that 12. So I can turn those both into 12s. So up top, 12 plus 1 would give us a 13. Negative 2 radical 3 minus another 2 radical 3 gives me a negative 4 radical 3. And then at the bottom, 12 minus 1, 11. So then looking 13, 4, and 11, looking at the numbers not in radicals, can we reduce those all by the same number? Nope. So that's our final answer.